Greetings. My name is Tim Stark. I'm a professor of civil engineering at the University of Illinois at Urbana-Champaign. This video is going to describe the pond leakage calculator. This pond leakage calculator is described in episode 9 of our podcast series, and this video is going to demonstrate how to use the calculator and input parameters into the calculator. So there are two main steps in the calculator, and that's shown on this particular screen. Step 1 is in the gray box, step 2 is in the tan box. The important areas are these blue cells that I'm pointing to. The blue cells are the ones that the user inputs. So the cursor is now on the dimensions of the pond. So in this particular example, the top width of the pond is 300 feet. The length of the pond is 500 feet, and I can change that to 600, and you'll watch all the calculations change. And then the next blue input is the pond depth. Then the green cells are the calculated values based on the user input. So the first calculated input is the total volume of the pond. This is a really useful calculation because it helps owners, engineers, designers figure out how big of a pond they need and the dimensions for the pond to handle a certain volume. In this particular calculator, the volume is in gallons. So this calculator uses imperial or English units. There's a corresponding calculator that uses metric units. These calculators are available on the Fabricated Geomembrane website at fabricatedgeomembrane.com. Across the top of the website is a menu. All the way to the right is a pull-down menu called Resources. And the fourth and fifth items on that pull-down menu are the pond leakage calculator and the panel weight calculator, which operates the same as this pond leakage calculator. Okay, the next input that the user places in is the hydraulic conductivity of the compacted soil liner. And the next input after that is the hydraulic conductivity of the geomembrane. And so these values are varied, and that gives the user how much leakage occurs out through the containment area or the pond if only a compacted soil liner is used or if a geomembrane is used. And this is important because this helps describe to owners, regulatory personnel, engineers, the benefits of installing a geomembrane. So for the example I have on the screen, the width of the containment area is, I'll make it 400. The length is 600. It's 25 feet deep. That gives 31.852 million gallons of overall volume of the pond. So if the compacted soil liner has a hydraulic conductivity of 1 times 10 to the minus 7 centimeters per second, you would leak 5,715.9 gallons of water or fluid from that pond. If a geomembrane is installed with 1 times 10 to the minus 12 centimeters per second transmissivity or permittivity, the leakage is only about 1.4 gallons per day. This assumes there are no defects in the geomembrane. Another calculator that's under development allows you to install a number of defects in the geomembrane and calculate the leakage. But this pond leakage calculator is just really for a comparison of using compacted soil versus a geomembrane. The next input is the cost of the water or fluid that's placed in the pond. In this particular case, I used a value of $25,000 per acre foot for water, making this a freshwater or potable water storage area. And so using the leakage of 5,715.9 gallons per day, that would mean the owner would lose $161,688 per year of water by not using a geomembrane. And so this is very helpful for convincing owners of the benefits of installing a geomembrane to line a containment area. Notice the leakage is so small with the geomembrane, there's no lost money due to leakage through the geomembrane per year, which is important because the cost of water at this particular example is $25,000. So step 2 is where detailed information about the containment area can be entered. So the depth is 25 feet, and that's from above. And then the amount of freeboard in the pond, and that's the area or the length of the side slope between the top of the liquid and the ground surface, if it's a below ground containment area. And then the pond top width and top length are inputted from above 400 and 600, and then the user inputs the side slope, 3 horizontal to 1 vertical, and then that allows the calculator to calculate the volume of the pond, which I showed you above. The last pieces of input are the thickness of the compacted soil. In this particular case, it's 2 feet. And that's needed because Darcy's law is used to calculate the leakage through the compacted soil liner. The geomembrane thickness is a nominal 1 inch, or it could be in millimeters in the metric calculator. If it's 30 mil thick, you could put in 30 mil, which is 30 thousandths of an inch. So I just use 1 inch. It doesn't make a difference because the hydraulic conductivity is so small. Okay, so then given the thickness, you can see on the right the leakage rate through the compacted soil. So if I just change this to a 5-foot thick compacted soil, you'll see the leakage goes down. But there's more cost to make the compacted soil thicker. And the hydraulic conductivity of the geomembrane can be varied from 1 times 10 to the minus 12 to say 1 times 10 to the minus 13, and that'll decrease the gallons per day of leakage even lower than 1.37. Okay, the last parts of the calculator are steps 3 and 4, where the user can see the individual calculations as a function of the depth of water. So if it's a shallow pond, you can see 5 foot of depth and varying the compacted soil hydraulic conductivity from 1 times 10 to the minus 4 to 1 times 10 to the minus 8. And there's the geomembrane. Notice here it's a little lower hydraulic conductivity, 1 times 10 to the minus 14. And these two tables of typical leakage rates for different configurations are used below here to plot leakage versus pond volume. And that's important because then the engineer can size the pond for a given leakage rate. So if they want to always maintain a certain volume, they can come in at a leakage rate to keep that volume and figure out what total volume of pond would give them that constant volume. And then the final graph is the money lost per day based on pond volume. So the horizontal axis is the volume of the pond, and the money lost in dollars per day due to leakage. So if you look carefully at the graph, the geomembrane is at 0. So it really doesn't matter. The hydraulic conductivity of the geomembrane is so low, the volume of the pond doesn't matter. The leakage is always low. Whereas the leakage through the compacted soil liner increases significantly because the bigger the pond, the more area that seepage or leakage can occur across or through the compacted soil liner. So I hope you enjoy the pond leakage calculator. It's a very useful calculator. Again, you can quickly change the dimensions of the pond and find an optimal size for your site to reduce the lost money due to leakage and the benefits of installing a geomembrane. If you have any questions, please send me an email at fabricatedgeomembrane@gmail.com, and you can download this video and the pond leakage calculator from fabricatedgeomembrane.com under the Resources menu. Thanks for joining us.